All right, right now my classes are working on determining whether or not a relation is a function or not. And so what they need to figure out is whether or not every input produces only one output, which is the definition of a function. If you have an input, you can only have one output. Every input has exactly one output. You have to just keep reminding yourself of that statement, and if you can figure that out, you'll determine whether or not something is or is not a function. So one thing that's tough about this section for students is they get a whole bunch of new vocabulary. They are used to X's and Y's. They have to understand that all of these are terms that we now use for X values. Input, independent, and domain. Those all are representing X's. When we're talking about Y's, or Y values, those are our outputs, our dependent variables, and that's our range. So when you get a list of ordered pairs like we have here and here, we can determine if it's a function or not by deciding whether or not every input has exactly one output. So the best way to do that is just focus on your X's. Your inputs are your X's, inputs are the X's. So does the input of 1 only produce one output? So I see 1 right there, and then I look at my other X's and I do not see another 1. So I'm not concerned about 1 producing anything other than a -2. I look at 2, which is another input, and I don't see another 2 anywhere, so it's only producing 3. 3 is only producing 6, and 4 is only producing 10. Because every input has exactly one output, this is a function. Now this second list of ordered pairs is a little bit different, and you might see why just by looking at our first ordered pair and our last ordered pair. Notice that we have a 7 as an input here and a 7 as an input there. Because you see 7 pop up twice with different outputs, every input here is fine, but the input of 7 is producing a 4 as well as a 2. So this relation would not be a function. And the reason for it is 7 has 2 different outputs. Then we go into mapping diagrams. So if I'm looking at this mapping diagrams are drawn with arrows. So for example, you'd have an arrow going from 0 to -3. Maybe 1 goes to 0 and to +3. 2 goes just to 2. And 3 goes to the 1. Now, when you see 2 arrows going off of an input, remember your inputs are your X's. The input of 1 here is producing 2 different numbers. We have 2 arrows going off of it. So if you see 2 arrows going off of an input, that is not a function because the definition of a function is every input can only produce one output. The input of 1 here is producing a 0 as well as a 3. Therefore, this would not be a function. Over here, if I were to do this, this is one that typically confuses kids because we might have an arrow going there, another arrow going to 1, another arrow going to 1, and then the only one that produces the 2 is the -4. A lot of times I'll have kids look at this and they'll say, oh, that's not a function because they see 3 arrows all going to 1. But keep in mind, the definition of a function is every input can only produce one output. The input of -10 is only producing a 1. That's its one and only output. -8 is only producing a 1. That's its one and only output. -6, again, same thing. So each one of the inputs only has one arrow going off of it. Therefore, this would be a function. For every input, there can only be one. Hopefully you're on the other side of that screen saying output, one output. Now what you're looking at is 2 table of values. We got an X and a Y column table. We got to determine if every input produces one and only output. And so again, you're looking to see if you have duplicates in the X axis or in the X column for this table. So I'm looking -2 produces a 2 and there's no other -2's in there. Don't get a positive and a negative confused. Those are different values. -1 doesn't pop up again and it only produces one output. But if you look here, we have 0 twice. 0 is producing a 6. 0 is also producing an 8. So this right here is the reason that this is not a function. If you go over to the other table, I've got -5, 0, 5, 10, and 15. None of these duplicate, so right away I can stop and say we're dealing with a function because every input is only producing one output. Let me give you another representation to make sure you understand how to do this in graphs. All right, now what we're looking at is graphs. The best way to determine if a function or if you're dealing with a function on a graph is using what's called the vertical line test. Vertical line test is going to show you if you have duplicate values for any given input. Remember, our x's are our inputs, also known as our independent variables, also known as our domain. So if I look here and I just go over and say 3 over, right? And I go to 3 and I go up the line, boom, there'd be a dot right there for 3. That would be the only dot on this graph for 3. Now, if you saw duplicate dots above one another, that would cause this to not be a function. But because we only have one and only dot, when we go over to 3, it's the same as if we went over to 4. You go up the line, boom, it hits right there. Same if you went to 1. You go up the line, you hit right there. Each one of these inputs is only producing one output. Therefore, this is a function. Okay, now the vertical line test works like this. You just draw a vertical line on the graph and it hit one time. Over here, it hit one time. Over here, it hit one time. If it only hits once, you're dealing with a function. This is an example of not a function because if I were to draw a vertical line right there, I'm going to hit here and here, meaning my input of, let's just call this 1 for the time being. If I put 1 into the function or into what I'm dealing with, I get 2 different outputs. Therefore, this is not a function. All right. Hopefully this makes sense. I want you all to study hard and good luck on your upcoming test.